Well, good afternoon, everybody, and thank you for joining us with our Get Into Code with iPad session. This is session number 2. So if you weren't there for session number 1 last week, or not last week, a few weeks ago, whatever it was, you can follow up on YouTube. Super. So a few welcomes and instructions before we go any further. So this is a webinar by the Greenwich Apple Regional Training Centre, and Apple Regional Training Centres deliver courses to build the skills and confidence of educators using Apple technology inside and outside the classroom. We are a community that share best practice and inspire excellence through teaching with Apple technology. There's 70 or so RTCs across the UK and Ireland, and you can find out more about them if you just Google RTC, Apple RTC. So a few welcomes from us. So I'm Tim Lings, I'm Director of Digital Learning here at Heronsgate Primary School, and I'm joined by
Ralph Forrest, Year 5 teacher here at Heronsgate and part of the computing team with Tim.
Hi, Andrew Barnshaw. I'm a Year 2 teacher here at Heronsgate Primary School, also part of the computing team with Ralph and Tim.
So a little bit more about us as the Greenwich RTC. You can find out more by looking at our Twitter page or our website, and you'll find details of any upcoming courses. So today we are going to be looking at an app called Swift Playgrounds that you can use for developing and coding on your iPad. There's going to be a chance for some hands-on exploration. We're going to model some stuff to you, and then if you've got an iPad where you are, you can join in too. It's an opportunity to join in and discuss as well. So last time we looked at Get Into Code with iPad 1, looking at commands, functions, and for loops. And today we are going to be looking at variables and conditional code. That's the kind of the way through what we're doing. So before we go any further, just a little recap about what you might need for this session. So on an iPad, you'll need the Swift Playgrounds app. It's free to download and install from the App Store. There is also a set of books that you can download on the Apple Bookstore. If you just search for Get Into Code Puzzle Adventures, I think I'll show you in a second. But also it'd be great if you are willing to join in, come off mute and join in a few activities with us as well. That would be fantastic. So we're going to be looking at variables and conditionals, how they work in everyday life. You're going to learn some simple activities that you can use confidently with your students. You're going to try out those skills on the Swift Playgrounds app and have a little connect about how that might connect in with the curriculum in real life, and then share your successes. But before we go any further, I always think it's good to start with a poll. So the poll question today is, how confident are you feeling with using Swift Playgrounds? So is it that you didn't attend the last webinar, but you're already really confident? Is it that you attended or watched the last webinar and you're feeling a bit more confident? Is it that you attended last webinar, but you still don't really know, or you didn't attend and you still don't feel confident? Good, okay, lovely. Fantastic, perhaps a few, oh, here we go. Super, so I'm just gonna end the poll now, and you can see here that the results are pretty split. We've got some people who've attended, some people who didn't attend, mix of confidence and no confidence. So hopefully by the end of today, you'll have a bit more of a clue about what's going on. Okay, so before we get going, we're going to hear from Steve Bunce. He's an Apple professional learning specialist, but not himself, just a memoji version of himself, telling us a bit about what variables are. So let me just...
In this part, we're going to think about variables. Variables are things which change. So for example, as you are travelling in a car, the distance travelled would be a variable. It keeps changing as you go further. However, your destination and your starting point may be the same, and we would call that a constant.
So there we go. So a variable is a container. It's something that can hold some data, and the thing that can be in the data can change. So maybe just to illustrate this a little further, I'd love it if Ralph and Andrew, you could just play a little game of rock, paper, scissors, if that's all right. So if I count to 3, and then you can either be a rock, a paper, or a scissors. You ready? 1, 2, 3. So Ralph wins. The scissor. No, hang on. The rock wins. I'm terrible at this. The rock wins. Rock, blunt, scissors. At least we didn't do lizard, Spock. That would be a bit too much. Okay, should we try again? You ready? 1, 2, 3. Oh, the scissors beats the paper. Ralph wins. Okay, best of three. You ready? 1, 2, 3. Scissors beats paper. Mr. Barnshaw is victorious. So in that scenario, the variable would be rock, paper, or scissors. Okay, if that makes sense. So the variable is something that holds that data, and it's something that can change. So at that point, so in that game, whichever it was, it keeps changing. It's not a constant, but there are kind of limits to the type of variable. So you couldn't have rock, paper, scissors, or goldfish. That wasn't one of the options. So when you have variables, you can set the kind of things that can live inside the container. So if we refer to the Everyone Can Code puzzles, this is a little book. If I just show you on the books app, here we go. You've got a range of Everyone Can Code books. So there's a student versions. We're looking at the puzzles one, and then there's a teacher guide. And the teacher guide has a whole range of activities that you can do with students. So it kind of goes through what the students see, and then it's got kind of extra cool stuff for teachers to look at, which often explain the activity or give you kind of a hint on how to do it a bit differently. But if we look here again, yeah, so learning about variables. So this suggests, if we look here, so it explains what they are, that variables are like containers that hold pieces of data. And they're all going to have different names. So for example, if you had your your address book, the different variables that you might name, like is the name of your friend, their age, their phone number, and then you would fill in those variables with different bits of data, and that would build up your lovely database. So if you're working at this with students, you'd get them to consider what different variables are, what might live in those variables. So we're going to have a little go at an activity now, and it will be great if anyone wants to come off mute and have a go. But we're going to suggest 3 variables for a planet top trumps card. So oh, here we go. I'm just going to launch this website. Here we've got dinosaur. Here we go. So we've got some information about planets. Perhaps if we went to have a look at Jupiter, you can see it's just going to load. But NASA clearly don't have a lot of money to spend on website hosting. While that's loading, let me just do a little split screen here. So I was wondering, if I can get this working. Come on, internet. Play. We could try Mars instead.
Jupiter's feeling a little slow this time of year.
I'm still having it's a bit of a long way to Jupiter. Maybe Mars is a bit closer. So the internet's working well today, but if, for example, you had a planet top trump here, and at the top, I've given you a first suggestion that you'd have, the first variable would be planet name. I've made it all one word, capital letter of the second word. And that would be a variable, and you can put in there the different name of the planet. And I wonder if anyone would like to come off mute and suggest what 3 other variables might be that we could just kind of slot in. Oh, the server stopped responding. This is... here we go. Mars is the coldest planet. And now it works. Excellent. So what kind of things do you think we could suggest? Anyone got any ideas? So a kind of a container of data that would be the same across all the different planets.
Planet mass, maybe?
Sorry?
The mass of a planet,
Yeah,
I think.
mass. I might even just have a go at editing this while we do it. Here we go. So we could have plan. This is what I'm like. Does planet have 2 M's or 1? That's one.
Just one.
There we go. So that's my first variable, planet mass. So we'd find out how much the mass of Mars is. Probably pretty big.
Planet.
Any other suggestions?
Planet distance, sort of distance from the sun.
Okay. Let's do. Distance from sun. So Mars would be different to Jupiter, which is different to Mercury, etc. And how about
planet's orbit? How long it orbit around the sun?
Yeah, so day's orbit, that's excellent. Here we go. So that's going to change. For example, Mars, it's 687 days in orbit. There we go. So you're already starting to get the hang of variables here. Fantastic. Look at that. Our first, our top trump card with its variables ready to go. Fantastic. So if you look at the the teacher guide, this has got some suggestions of how you could have that conversation with your children, the students in your class, to help them get the idea of what a variable is. So we're now going to have a go at trying this out. Now, to try out variables, it actually uses the second playground in Swift Playgrounds called Learn to Code 2. And then there's a couple of other different starting points that they use, spirals and answers. We won't look at them, but these are places that you can explore the idea of variables a bit further. So when you open up Swift Playgrounds, you need to actually download the second book, Learn to Code 2. And within that, the first kind of section looks at variables. And I'm now going to hand over to Mr. Korish, who's going to tell us more.
Okay, thank you. Let me just quickly share my screen onto my iPad. Cable share. And Mr. Lings, confirm that's all there? Or Mr.
Yeah,
Barton?
we're all good.
Excellent, lovely. So we've got, as Mr. Ling said, we've got Learn to Code 1 and Learn to Code 2, which you looked at Learn to Code 1 last time, and this time we're having a little look at a couple of things on Learn to Code 2. And on Learn to Code 2, we are looking at variables. So if I just quickly press that button, you can see sort of the first chapter. This is the first chapter of variables, as Mr. Ling's just said. Sort of variables are things that can change the things that we are looking at right now. So just quickly go through the introduction, and then we'll have a look at our first level, keeping track, which is what we will quickly do together, and then maybe you guys can have a go at that yourselves. So going through, as we said, thinking about the names on and phone numbers you store on your contacts list, maybe far more than you can remember. So coders store information using name containers called variables. So these are the things that could change in your contacts. You could have different names, they could be different ages, phone numbers can change. So a contact in your list. A variable doesn't change its information unless you change it yourself. To create a new variable, in terms of coding, we would use VAR, short for variable, followed by the name for the new variable, and then a value. So in this case, we used to have a look here, new contact, VAR name equals Maya or Mia, and then VAR age equals 19. You see they've got that equals followed by the sort of value, and the equals thing is a setting that sets the value of the variable. So there we go. And you can see as you change the age, it will change it on the contact. And every time you can have a different calculation. You could have, as it says here, you could just simply type in the number, or you could do a calculation. The current age +1. So when it goes past that person's birthday, it's age +1, and that keeps changing. Using arithmetic operators such as that to add, subtract, multiply, divide. And then after you create a variable, the type of information it stores never changes. And we can't assign a value type. So for example, you'd have to type in the number there. So if we start coding and having a little look at keeping track. So it's asking us to create a variable to track the number of gems collected. Oh, let's get rid of our background music there. I might keep our little sound effects because they're quite fun. And so for this puzzle, you need to keep track of how many gems you're going to collect. Well, obviously in this level, you can see a nice simple level. Our byte is just going to be collecting 1 gem. So in order to do that, we need to create the variable using the VAR thing that we talked about. And it gave the example of age. No, you're quite annoying, so I'm going to turn your sound off too. And starting us off, you can see at the bottom there, variable gem counter. Now at the moment, we've collected no gems because we haven't moved yet. So when I click on that value, that button there, okay, we click on that, and I want to simply type 0 because I haven't collected any gems yet. So at the moment then our variable of gem counter is at 0 because I have not collected any of the gems. Now, the code itself to go and collect the gem is exceptionally straightforward for this level. So when we type in the and we type in the code to collect the gem, as you would have done last lesson on the Learn to Code 1, moving along, we look for move forward. Somewhere along here, here we go, move forward, and then he has to do it twice, move forward, and then collect the gem. Now, what we need to now be able to do is obviously if we collect the gem, then the counter is going to change. All right, the counter total is going to change. So we need to look at where the variable is along here. In this case, it's called gem counter. So I need to press that. Now something then pops up slightly different there. We've got to press that equal sign to show that we are looking to change the total. So equals there. And now, because we're collecting this gem, we'll have collected it, it will go up to 1. It will go up to 1. So let's run that code together and see if everything I've done works correctly and our gem counter variable is going to move up to 1. Perfect. We've declared our first variable. Using this variable, you can now track the number of gems your character picks up. Even though you only picked up 1 gem this time, you're on the way to creating more intelligent ways to track and store information using code. So if we were to go on to the next level, it would then start talking about maybe using the +1. So every time you collected a new one, it would add to the total itself instead of having to type in each time gem counter equals 1, gem counter equals 2. You could sort of do the add 1, so it would then start doing it itself. So, Mr. Links, I believe that brings me to the end of demonstrating the first 2 levels. So I will pass
that
back.
is correct. Thank you very much, Mr. Corey. So I'm just going to share my screen again. So if you were completing these levels with your students, you would want to. There's some other playgrounds that it suggests. So, for example, you've got some starting points. So there's one, or they're called challenges. So, for example, spirals. So it's kind of a challenge where there's a playground and there's a whole lot of different variables that you just have a play with. Oh, what happens if I change this variable? And you can see how the spirals change. So it's that more exploratory approach. But just wanted to show how, because a lot of this is teaching the concepts of coding so that students are learning what on earth's going on, not just how do I get to the end of the level, but how does it work? Super. So it's now your turn. If you've got an iPad with that app, please feel free to press the home button, open up Swift Playgrounds, download, get started with code 2, and have a go at the very first levels, all about variables. You've got 3 minutes, and we'll be back in 3 minutes. So don't worry, Zoom will keep going in the background. Do have a go and see how you do. Fantastic. So hopefully you've had a chance to have a little play with variables. So going back to the books here, if you were following the books as a guide for teaching the lessons, you would introduce the idea of variables. You'd get students to have a try the different levels it suggests. They've got some suggestions on how to complete them. But what's nice is there's also, after that, is they connect. So it's thinking about ways that they can connect what they've learned about coding into their kind of everyday normal life. So one suggestion that they give here is that you could make a hall of heroes so that you could engage with different people in history or who are still alive that they're really impressed with. And a bit like we're making top trumps with planets, you could make a hall of your hall of heroes and then think that actually what are the different variables that you want to include, you know, photo, name, biography, greatest impact, etc. So it's ways that you can take that understanding about variables and apply it in the real world. Super. Okay, so we've done variables. We're now on to conditional code. So back to Steve Bunce. Let's see what he's got to say.
This session is about conditional code. What happens depends on something. Think about weather conditions. If you think it is going to rain, you might take an umbrella. But if you think it is not going to rain, then you don't take an umbrella. What you do depends on something else. So we're going to play some games and find out more about conditional code.
Love it. So we're going to start off with a Zoom version of if you have a da-da-da, put your hands up. So if you're on screen, feel free to raise your hand. But if not, I believe in Zoom, there is the option to reactions, I believe. So you can, you know, maybe a thumbs up like that. See that there? If this applies to you. So if you're on, what's going on here, right? If you are wearing shoes, thumbs up or hands up. So I'm wearing shoes at the moment. Anyone else? Great. Mr. Barnshaw, maybe he's taking them off. He might have. Okay,
my shoes are off.
Okay, amazing. I didn't imagine that was actually an answer. Okay, how about this one? If you had breakfast today. Good. Okay. Put your hands up if you, I'm trying to think of an example, like playing the drums. Okay, good. And how about this one? And I'm going to make use of Zoom emoji at this point. So the reactions, if you have ever played golf, I would like to see a laughing emoji. There we go. Look at that. So here we go. That's just getting an idea of conditionals. So if something, then something happens. So if you were going to use, for example, the Everyone Can Code Puzzles teacher guide, there's an activity about someone says, so if you're doing this, then do this. If not, then do that. So it's just getting students used to this idea of conditions for an action, and then conditions if the actions isn't met or a different action. So that's quite useful. Now to try this out, we're going to go back to Learn to Code 1. And there is the conditional code introduction, which I believe that Mr. Barnshaw is going to take us through. So again, it's got a range of different puzzles we can try. We're not going to try all of them, I believe just the first 4 on there, because it might take us absolutely forever. But these are really great puzzles. And remember, in the Everyone Can Code books, it's got a lot of detail about these. So let me just show you this. So conditional code, and what is particularly useful is there's the teacher guide, which suggests how you actually solve them. So it gives you some ways that you can teach it, how you can get those puzzles solved and work through them. So it's not leaving you in the dark about how to do that. All the resources are there. So I'm now going to stop sharing and hand over to Mr. Barnshaw.
Thank you very much. Let's get my screen shared here. Oh, super, great. So this is just the part of the book that I was just reading on here. And as Tim said, I'm going to have a go at conditional coding, which is in Learn to Code number 1. So conditional code, how do you plan for the unexpected? If you hit a traffic jam, you may need to change your route, which I imagine has happened to everybody in here at least once before. In code, you plan for different conditions using an if statement. If the light is green, bike walks forward across the street. And this is what that would look like as code. To write an if statement, use if and add your condition, which can be true or false. So the statement here is if light is green, then the condition would be bike walks forward across the street. And the bike to walk forward across the street in Swift Playground would just be move forward. So if light is green, move forward. Now, there is another element to this called else. If the condition is false, you can use else to specify a different code to run. And we'll come onto that in a bit more detail once we start coding. So let's have a look here what our first level is. It's checking for switches. Let's tap to enter code. Let's see our level up here. Make sure the sound is off. Most importantly, though, I need to change my character because I like using the little blue dude. So let's pick you. So here we're going to toggle a switch that's already open. The switch will close. We need to put if statement in to check if that switch needs toggling before we do. So tap to enter code. I can see we need to move forward first. So let's go move forward 1 and move forward 2. And then we need to have if, which is here, if. I'm going to tap on the condition So if the condition I'm going to choose is on a closed switch, if my byte is on a closed switch, I want him to toggle that switch. That is for the first one. So I need to move forward again and add another if statement here. Condition is on closed switch. Then toggle that switch, please. Move forward again. Oops. And if on a closed switch, code, toggle that switch. Okay, let's run that code. That should work. So each time you press on code, those switches will randomly decide which ones are on, which ones are off, which is why we needed the if statement. So it's just turned those two on, and it won't do anything on the last switch because it was already on. Super job. Let's go to the next part here. So this is the adding the else if element. So use if, so the goal of this one, use if and else if to toggle a switch or collect a gem. Again, try running the puzzle a few times. You'll find that switches and gems both appear in random places. To figure out whether to toggle a switch or collect a gem, use an if statement to check one possible condition and an else if block to check the other. Okay, so let's have a look what we need to do here. We need to move forward once, do some of that code, move forward again, and do the same code again. So let's tap to enter. First, we want to move forward. We want if. So the first condition we're going to say, if on a closed switch, we want to toggle that switch. Now, if I press the two dots at the bottom here, I can now add else if statement. So let's add that element in. And the other condition is going to be collecting a gem. So else if the condition is on a gem, I want byte to collect that gem. So that's move forward. That's going to satisfy the first place. We need to do that again. So move forward. If the condition here is on closed switch, code, toggle switch. The two dots, add else if statement, is on a gem, and then collect that gem. Let's see, let's run the code. So it's going to be randomly selected here. We have two switches. Super. Let's run that code again and see if it changes, just to show you that if it does change to a gem, the code will allow byte to collect that gem. Perfect. So there's no switch, is a gem, so else collect that gem. Super. Okay, let's see what the next challenge is. Looping conditional code. The goal here is to use an if statement inside a loop to toggle a switch or collect a gem. So much like the real world, nobody likes doing the same thing over and over again. So let's make use of looping. So we just have to type that code in once. So let's see how many times we need to move forward here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I believe it's 12. So let's put that number in there, 12. Okay, and it's already given us move forward, which is great. So move forward, we need to have if first condition is on a closed switch, we want to toggle that switch. Let's click on our two buttons here, add else if statement. We also want to, if is on a gem, we want to collect that gem. Let me just read over that code. That looks like it's going to work. So let's run the code, and I'm going to run this a bit quicker because I don't want to watch this at slow speed. So as he's going through, he's collecting a gem or turning the switches on. Super, great work. And just like the previous level, if we was to run this again, the gems and switches are random. So that first space is a switch gem switch. Let's see if it changes this time. Yes, it did change a bit. So, and it's still going to collect all the gems or flip the switches because that's what we've asked it to do in the code. Okay, now I believe I was going to do 3 levels. Tim, I just want to check with you. I can have a go at this 4th one. I mean,
I think we could. I think it's quite a lot of head scratching, which is
this
great.
one. Yeah.
But maybe on Zoom it might not work so well.
Okay, cool.
But feel free if people want to have a go at defining smarter functions.
Well, yeah, perhaps let's leave it with those 3, and then maybe if anybody wants to see this next one, I can give it a go.
Super. Well, thank you, Andrew, for that. That was
no problem.
Epic. So we've got a little bit of time now for you to have a go. So just have a go at those 3 levels, checking for switches using else if and looping conditional code. You'll find them in the Get Started With or Learn to Code 1, and then it's under conditionals. Learn to Code 1, conditionals. So those 3 levels there. So you've got 6 minutes. Do have a go. If you're like completely stuck, feel free to come off mute and ask a question or pop something in the chat. We're still here. Okay, 6 minutes. Off you go. Time's up. Okay, fantastic. So again, if you look at the Everyone Can Code Puzzles teacher guide, there are some resources about how you could connect with the wider world with what you're learning about. And here there's a suggestion about looking at the awareness of the user community when developing apps. So here, imagining what it's like to be in someone else's shoes. If you were someone else, what would that be like? Super. So that's the end. We've gone through variables and conditional code. So if you are the tweeting sort, please do use hashtag #AppleRTC or #AppleEduChat on Twitter. If you are already an Apple teacher, you are now in the position definitely to get yourself an Apple Teacher Swift Playground badge. So the Apple Teacher Learning Center, yeah, that's what it looks like, people, is like this. If you visit, I'm just going to press the home button and go there. So if you visit appleteacher.apple.com, hopefully they have better servers than NASA. I'm assuming so. So appleteacher.apple.com, there's a learning center here with lots of great stuff, but you can perfect your skills. I've gone too far. So once you've done your foundational skills, you can look at lesson integration, and one of them is Swift Playgrounds badges. So you can brush up on those skills, but you can, so you first of all, you become an Apple teacher, and then you can explore the resources, and then you can take some quizzes and earn your badge. So you can look at the Swift Playgrounds app, some Swift Playground code stuff, coding concepts, coding in the classroom. And having done this, I would say you'd be pretty well placed to answer some of those questions and get that. Fantastic. Super. They do get a little bit more complicated and codey when you get to this point. But yeah, definitely something that's worth exploring. So we've got one more Greenwich RDC workshop this academic year, which we're looking at Shobi, which is at the end of March. And we have got a special guest from Shobi coming to help do that with us. So that should be great fun. But that's all from us. So thank you very much for joining us, and hope to see you at a future RTC event. So thank you very much for your time.
Thank you.
Thank you. Bye-bye.